YouTube viewers. In this video, what we're going to do is we're going to perform a hypothesis test using a t-distribution. Now, a t-distribution is similar to a normal distribution with the exception that it has heavier tails. So the hypothesis test that we're going to perform is we're going to test whether a new teaching method improves test scores in a class of 20 students when the population variance is unknown. So what we're going to do is we're going to perform this hypothesis test in Python. And in order to use Python, we have to import 3 libraries. So the first library is going to be NumPy SNP, and that's the numeric library. And the second library is going to be import scipy.stats as stats. So the stats is the statistical module in SciPy, and SciPy is a scientific library. And then we're going to import matplotlib.pyplot as PLT. And so after we have imported our libraries, what we're going to do is we're going to define our test scores, and our test scores are going to be defined in a list of 20 numbers. So after we've defined the test scores, then we define the population data. So the hypothesized mean is 85, and the sample size is the length of the test scores, and that's going to be 20, I believe, because the question says 20 students. So I believe it's going to be 20 test scores. So then we're going to calculate the sample statistics. So the sample mean is the np.mean test scores. The sample standard deviation is np.std test scores with a degree of freedom of 1. And the standard error is the sample standard deviation divided by the square root of the sample size. So we're going to perform a one-sample t-test. So your t-statistic is the sample mean minus the hypothesized mean divided by the standard error. And your p-value, which is a percentage, is the stats.t.sf, and SF stands for survival function, brackets np.abs, and abs stands for absolute value of the t-statistic, comma, and the degree of freedom equals the sample size minus 1. So the sample size in this instance is 20, so it's going to be 19, so 20 minus 1. And then we're going to multiply that by 2 to give you a 2-tailed t-value, p-value. We're going to calculate our t-critical value for a 95% confidence level. So t-critical equals stats.t.pphalf, and it's going to be 0.975, df, sample size minus 1. And the reason why it's 0.795 is because it's a 2-sample test. And then because it's a 2-sample test, it's going to be 0.0250, I believe, is half of 5%. So that's where you get 0.975. And so it's going to be half of 5% on each side. So now what we're going to do is we're going to print the sample mean and the t-statistic and the p-value. So your sample mean is 86.85, and your t-statistic is 1.57. Your p-value is 0.1325. So 0.1325 is greater than 0.05, so that means you have to accept the null hypothesis or fail to reject the null hypothesis as there is no significant improvement in test scores because the sample mean is 86.85. And the hypothesized mean is 85. So it very slightly improved it. And that's why the null hypothesis was not rejected, because it was a very slight improvement. So now we're going to check if the p-value is less than 0.05, then you reject the null hypothesis. Otherwise, you fail to reject the null hypothesis, but the p-value is greater than 0.05, so we fail to reject the null hypothesis. So now what we're going to do is we're going to visualize our work. So you're going to plot the t-distribution and the critical regions. So x equals np dot line space brackets -4, 4, 1000, and those are your t-scores. And then y equals stats dot t dot pdf, and pdf is probability distribution function, brackets x, df equals sample size minus 1, so that's 19. So plt.figure brackets fig size equals 6, 4, and then plt.plot brackets x, y, color equals blue, label equals t-distribution. We're going to highlight the critical regions, plt.fill between brackets x, y, 0, where x is less than t-critical or x is greater than t-critical, color equals red, alpha equals 0.3, label equals critical region. And now we're going to make some vertical lines in the chart. So plt.axv line brackets t statistic, color equals purple, line style equals dashed, line width equals 1.5, label equals t statistic. Then plt.axv line brackets negative t critical, color equals green, line style equals dashed, line width equals 1.5, label equals f neg t critical. Then plt.axv line brackets t critical, color equals green, line style equals dashed, line width equals 1.5, label equals plus t critical. So now we're going to add labels, title, and legend to the graph. So the title is one sample t-test for t-scores, and X label is t-score, Y label is probability density, you get a legend and you get a grid. So it says here that it's a one sample t-test, but let me just double check this. It's a two-tailed. It's not a one sample t-test. So let's see if that works better. So your X label is your t-score and your Y label is your probability density. I'll go ahead and leave a one sample t-test here for the time being, even though it is a two-tailed t-test. And it's a legend and you get a grid and we're going to show it. So now you have a one sample t-test for test scores, but I don't think it's a one sample t-test. I think it's a two sample t-test. And the reason why, if it was a one sample t-test, your critical region would only be on one side of the t-distribution, and it would be bigger. So your t-distribution is the blue curve. Your critical region is in the pink. So if it was a one sample t-test, the critical region would be larger, but it would be in only one side of the curve. And it said at the beginning of the program that it was a two sample. So I think that was just a bug in the code. So your T statistic is 1.57 and it's in purple. Your negative critical is negative 2.09. It's in green. And your positive critical is plus 2.09 and it's in green. And your T statistic is within the confidence interval of the T distribution. So that means that the null hypothesis is accepted, or the null hypothesis, they failed to reject it, which means that there's no significance difference between the population mean and the sample mean. Now, if let's just say hypothetically, the T statistic was 2.15, then what would happen would be the T statistic would be outside, would be in the critical region. And when the T statistic was in the critical region, this would also affect the p-value, and it's highly likely that the p-value would be less than 0.05, and so the null hypothesis would be rejected. But in this instance, the null hypothesis or is accepted, or they haven't failed to reject it. So that's it for this particular video. The next video, we're going to be working on a chi-square distribution, so I hope you watch it.